Hello friends. So, so we have seen the specific functional requirement of chapter number 4. In this, we are going to learn the Sun model. So the Sun model is a requirement mapping technique that assists you in recording at the level that allows your non-technical users to understand the intent of your analysis. So we have seen the example of Sun model. We'll go in more detail in the next slide. So this is a typical Sun model. Here a person's dimensions can be stored, like the person has the dimension, like a person is having a title, a last name, first name, person key, and then there is a dimension for location, like the location name, altitude, longitude, latitude, location key. Then the dimension date, like the day, month, year, and date. So let's see one example. Now Dr. Jacob is Sun model is recorded in this example. So you can see that this information, how it has been recorded. So just let me take the pen. Yes. So here you can see that the sir's title is doctor, first name, last name, and the person's primary key is say 1 is recorded here. Then the dimensions are recorded as the Rupa Nui Easter Island. Then the person's altitude, latitudes, longitudes, and location key is recorded here. Then the date dimension, that is day is 5, month is April, year is 1722, and the date key is recorded here. So now this is the information of Dr. Jacob. Let's go to the next slide. So you can see that how the information has been recorded. This is the information of the person lives at a particular location. So now let me go to the next slide. A dimension is a structure that categorizes facts and measures to enable you to respond to business questions. A slowly changing dimension is the data structure that stores the complete history of the data loads in the dimension structure over the life cycle of the data lake. That means we say that this is a slowly changing dimension, and if the slowly changing dimension, it happens that a person's address will remain constant for many years, but afterwards the person may shift to a new address, so the address may change over a period of time. So now here Dr. Jacob, he has changed his location. So you can see at the bottom the first name, last name is written here, but the address was, first it was Easter Island, now it is Netherlands. So we have to keep the record of both the addresses, or we have to keep the latest address, that we can decide. So the slowly changing dimension type 1, it will always record the first place that Dr. Jacob lived and ignores the second. So the first place was Easter Island. So every time the information will store the first name, last name, and the first address. This is SCD type 1. Then SCD, that is slowly changing dimension type 2. It keeps the complete history. Complete history means there are 3 ways of keeping the history. First is versioning. Versioning means it keeps a log of the version number, allowing you to read the data back in the order in which the changes were made. Like the person's address must have changed many times, so we can track the order in which the address has changed. Another method is flagging. The slowly changing dimension flags the latest version of the business data row as 1 and the rest as 0. So we can quickly identify that which is the latest address or where Dr. Jacob lives now. Then the effective date. The SCD keeps record of the period in which the specific value was valid for the business data row. So we can store the date or we can store the duration for which it was valid. So let's see the different types. Now the best SCD for data is data type 2 with effective date. So we easily come to know that in which period the person lived where. So for example, Dr. Jacob lived in Middelburg, Netherlands, and then in Easter Island, but now lives in again Middelburg, Netherlands. So how the information will be stored? There are 3 records for Dr. Jacob, and the addresses are first Middelburg, Netherlands, then second Easter Islands, and again Middelburg, Netherlands. Now type 2 SCD type 2 records only changes in the location of Dr. Jacob. So if the other data like first name, last name, everything is constant. So for this data the version is 1, but the location has changed. So 3 versions of the location has been created. The first version is Netherlands, second version is Easter Island, and the third version is Netherlands. So this is also one way of keeping the data. Then comes the intra-Sun model consolidation matrix. So the intra-Sun model consolidation matrix is a tool that helps you to identify common dimensions between Sun models. Let's assume our complete set of Sun model is only 3 models. We have only 3 models. So the first Sun model records the relationship of birth with its direct dependence on the selector, event, date, and time. So you can see this Sun model that keeps the information of birth. So here the dimension event has event domain, event type, event name, and event key. The date has day, month, year, and date key. The time has seconds, minutes, hour, and time key. So these are the 3 dimensions that are stored to store the information of a person's birth, date, and time. Now the second Sun model records the relationship for leaves at with its direct dependence on the selector's person, date, time, and location. So you can see this person's detail, that is person's title, last name, first name, and person key. Date dimension is also present, time dimension is also present, and the dimensions for location is also present. So this is our Sun model 2. Now Sun model 3. Sun model 3 records the relationship for owns with its direct dependence on the selector's object, person, date, and time. Like if you see this Sun model, we are having owns. So the object domain, object type, object name, and event key is stored. Then the person dimension has all the information about the person. The person date stores the information about the date, and the time dimension stores the seconds, minutes, hours, and time key. So this is Sun model 3. Now intra-Sun model linkage. So this intra-Sun model linkage, it shows how the models are linked to one another. So we have 3 Sun models: birth, leaves at, and owns. Now we have SDC 0, type 2, and type others are all type 2. One is to store date, time, person, object, location, and event. So how these are connected is shown in the table. Like birth is connected to date, time, and event. Leave set is connected to date, time, person, and location. Owns is connected to date, time, person, and object. So from this we come to know that where the person lives, what the person owns, and where the person lives at a particular date and time. So this interconnection shows the linkage between the between the Sun models. Now the non-functional requirements. So let's see this non-functional requirements in the next